This is Euclid Book 4, proposition number 13, and what we're going to do, this will be a multi-parter. I'm sorry, there'll be more than one part to this because it's very, very extensive. Alright, we have an equal angular and equilateral pentagon. Now, in order to draw an equilateral and equal angular pentagon, you have to start with a circle and a tangent line. And I have been telling you this the last couple of videos. You draw your circle, you draw your tangent line, you make one angle 72 degrees, the other angle 36 degrees. When you do, you draw all the three sides, and what you'll have is a triangle in which the base angles will be 72 degrees and the remaining angle will be 36. Okay? Once you have that, you bisect the base angles. As soon as you do, you have all 5 points to make the equal angular and equilateral pentagon. Okay, now that we have this drawn, we're going to bisect two angles here. Which ones are they? They are B, C, D. This one will be bisected. And then CDE, CDE. This one will also be bisected. This one here and this one here. Once we do that, we have to draw the lines CF and DF. Well, here's CF here and here's DF here. Okay? Now, if you draw this indefinitely and you draw this indefinitely, at a certain point they're going to meet. And where they meet, well, that'll be point F. And then what you're going to do is you're going to draw FB, FA, and FE. All right. Now, once you've drawn all this, you have what it takes, basically, and we'll show you the rest of it in a little bit. We're going to inscribe a circle, a perfectly round circle, inside this pentagon. Okay? Now, drawn on the little lines, we have to first of all say that BC here and CD are equal in size. If you were to measure this and you were to measure this, they'd be exactly the same size. Well, we've already established that as a given because we just drew an equal angular and equilateral pentagon. So obviously BC and CD are exactly the same size. Well, CF is equal to itself. If you draw this, it's equal to itself. Okay, there's CF right there. Now, because we bisected BCD, we came up with two angles, BCF and DCF. BCF and DCF. Okay? And these two angles are exactly equal in size. If you were to measure them, you'd find out that these two angles are equal in size. Alright. Because of Euclid Book 1, proposition number 4, we can also then go on to say that line BF and line DF are exactly the same size. Well, here's BF here and here's DF here. These two lines are exactly the same size. And then we can go on to say the triangle BCF and triangle DCF are exactly the same size. So far, so good. Now, we then can go on to say that angle CBF and CDF are the exact same size. So, where is CDF? Alright, let's see. CBF. Well, where's CBF? Well, here's C, here's B, here's F. So that one right there. And CDF. Well, here's C, here's D, and here's F. So these two angles here. Sorry about that. Those two angles there are exactly the same size. Now, angle CDE. Well, where's CDE? CDE. Okay? It is double the size of CDF. CDF. How do we know this? Because CDF and FDE here, they're both exactly the same size due to the fact that DF bisects CDE. And we told you that earlier on in the proof. Okay. Now, angle CDE equals angle ABC. Well, here's CDE, and here's ABC. This angle here equals this angle here. And we know this because we now have an equal angular and equilateral pentagon. Alright. Now, CDF equals CB, let's see, CDF equals CBF. CDF equals CBF. This one to this one. And angle ABC, ABC, is twice the size of FBC. Well, here's F, here's B, here's C. So this whole angle here, this great big one here, is twice the size of this. How do we know this? Because BF bisects ABC. All right. Now, that means that angle ABC is twice the size of CBF. ABC is twice the size of CBF. CBF. Okay, so this great one here is bigger than this, twice the size of this. ABF equals FBC. ABF, here, ABF equals FBC. FBC, this angle here is equal to this angle here. So now we can safely say that this line here has bisected ABC. Alright, that's the first part of the proof. I will tell you more in the next video, so stay tuned.